Welcome back. In this lesson, we're going to take a look at using the map algebra tools, the raster calculator in ArcGIS, which allows us to subset rasters to basically perform selection-like queries to create new rasters. So to get started, we'll expand the map algebra toolset and see just the one tool in it, the raster calculator. And when I bring it up, I get a calculator-looking thing. And on the left here are layers and variables that I can use. So the layers that are in my table of contents here, which is a land cover dataset, NLCD, National Land Cover Dataset, an aspect raster, which is the direction that cells face, the slope raster, and a digital elevation model. And on the right, I have a bunch of functions I can use. There are some more that aren't in here, but we can use basically any tool in Spatial Analyst from within here, but we can start to combine these things to create more complex workflows. I'm going to show you just a few simple ways to subset rasters using the raster calculator right now. So to start with, let's kind of play with the slope raster a bit. Let's see parts that are less than, let's say, 30 degrees. So slope less than 30. So I can double click the slope raster. I put in here and say less than 30, and I could get that straight out of here as well. And I'll click OK, and it's going to run, and it's going to go through this entire slope raster and find all the areas where the slope is less than 30 degrees for me. So that's pretty cool, and it gives me this 0 and this 1 binary response back. 0 means it's not less than 30, and 1 means it is less than 30. And if we zoom in, we can see that most places are less than 30. And only the spots that are in red seem to be highlighted. So maybe I should have seen that only the highest amount here are 30 or more. So let's take a look, and let's say we actually want everything that's less than 7. So we can run it again. It's pretty quick, right? And I can say slope less than 7. And I'll click, or I'll give it a name, slope LT7. And we'll run it again. And that's a little more interesting. So let's make the zeros, the spots that are not less than 7, let's give them no color. And then the ones are the spots that are less than 7. It's all the flat spots here. So we'll make that green so we can see it a little better compared to the other raster. And if we turn this off, we could overlay it on our digital elevation model or something, or just see the locations that are less than 7. We have a new raster that gives us only the spots less than 7. That's handy. Let's say I also want to find all the spots where the aspect is facing kind of to the south, so it has good solar exposure. So let's use the raster calculator, and let's say aspect greater than 112, because that it starts to put it in from the southeast, and less than 247 before it leaves the southwest. So we'll do that, and then we'll say and aspect less than 247. So aspect is basically between 112 and 247 here. Aspect southwest, and I'll say OK, and it's going to run it for me. It looks like it failed. So I probably did something wrong here. And I did, and I forgot to group them. So it needs to run these separately. It needs to compare the aspect here and compare the aspect here, and then bring these together. So it finished, and it gave me all the spots that face to the southwest here, which is great. But here's where the rest of that power comes in, is that AND operator that I just used to combine two aspect calculations, I can also use on the rest of these results. So maybe I want to know where the slope is less than 7 and the aspect faces southwest because I'm looking for a flat area to put in some solar panels or something like that. Well, I can use the raster calculator again, and I could do just aspect southwest and slope less than 7. Call it flat southwest areas, and I'll click OK. And it finishes, and it gives me only the spots where those two coincide. So let's make the 0 spots hollow again. And now we have only the spots where the aspect faces to the southwest and it's relatively flat. It's less than 7 degrees. So we get this kind of suitability analysis where we can combine factors to say, where do specific criteria coincide? Where are my criteria met? And we have it in this pretty simple tool and pretty simple language in that tool. And if I want to, I can verify that I'm not getting more than I expected by taking a look at these other layers. And we could see the parts in the green that were filtered out here because their slope was not less than 7. So, okay, I want to show you one last thing. And here's our land cover data. It's a slightly different color mapping because I clipped it. But let's do a quick filter to just the urban areas, which if we needed to confirm, I joined in the attribute table that we used in a previous lecture. And just the developed urban areas are in the 20s here, 21 to 24. So similar to what we did before, maybe I just want a new raster that is only the urban areas that I could use either in my suitability analysis or something else. So I'll choose my National Land Cover Dataset raster, and I'll say it is equal to, and in this case we're using double equals sign. That's actually the comparison operator. SQL, the language we use on vector data, uses the single equals, but I'll just do this. I'll say double equals 21, and then we'll use the pipe for or, and remember I need to put these in parentheses now. So and then I'm going to copy this and I'm going to paste it a few times, and this is the simple way to do it. I'm going to say it equals 22, 23, or 24, and I'll chop this off the end. And so basically what I'm saying is, give me a raster where the National Land Cover Dataset equals to the value 21, which is the developed value, or this pipe value means or, the National Land Cover Dataset equals to 22, still a developed value but a different one, or the pipe again, National Land Cover Dataset equals to 23, and then or with the pipe again, the National Land Cover Dataset equals to 24. And I'll name it urban areas. I'll say OK. And the raster calculator is running. Let's take a look at the results again. And it finished. And again, 0 means not urban, or 0 means not selected, and 1 means it is. And if I turn off the National Land Cover Dataset, I get this pattern of what looks like urban areas and highways to me. So I was able to adequately select that data out. There's so much more to the raster calculator, but think of it as a sort of selection, except that you don't get the original values back. There's a workflow that would allow you to get the original values, like the 21 to 24 that we just used to create this no and yes value, this 1 or 0, yes, no. But I'm not going to show you that in this video, as it'd take too long. But it's a great way to find out where specific conditions are met using rasters. I really like the raster calculator. You'll get some practice with it in some of the tutorials in this class and the following ones too. So it's a powerful tool that you should know about. Okay, that's it for this lecture. In this lecture, we used the raster calculator to subset rasters and use it to find where certain criteria are met. I hope you find it a useful tool. See you next time.